Enjoy the lectures, enjoy the videos, enjoy everything. Once again, my name is Dr. Sari. So this course, you need a bit of thinking, but please note that you are going to pass the course. That I know in my bone of bones. Nobody fails except the person who is praying to God to fail. Okay? But other than that, nobody fails this course. I don't even see that happening. Okay? But let me know early on what is working and what is not working for you. Okay? If something is not working, let me know about it. Okay? I do surgical operations. If you are having problems in the course, let me know. I'll do 60% assignments, 40% exams, or 50-50, or 40-60. Okay, I've not decided yet. So that's what I'll be doing in general. So please take note. If you have a question at any point in time, raise your hand. Raise your hand, use the icon to raise your hand. I'll see it immediately. I will handle it. I ask a lot of questions, very interactive. If you have an answer, you raise your hand and then you let me know. So let me start. Let me start to welcoming you all. Management science is the name in business schools, in most business schools. But in other departments like engineering department, mathematics department, economics department, it is called operations research or operational research. What is it? It is a scientific approach to decision making. Now, let me tell you something. During the war, okay, the Second World War, what happened was that the soldiers, the military, wanted to develop strategies to be able to counter their enemy combatants. And in the process of doing that, they developed those computational complexities. Strategy. You know, in the military, there's a lot of war that is going on. Okay, lots of war. So they developed these algorithms, this strategic procedural analysis. And over time, these algorithms, these strategies, these procedural analysis were adapted to health, were adapted to businesses, were adapted to engineering, to education, and to real life. And when they did, it became known as management science. Management. So management science actually emanates from war. Those are war strategies. And that is what today we've seen the models that have been applied and we are using them a lot. The algorithms, okay, of management science or operations research. And when I say algorithms, I'm talking about the procedural analysis, the procedures, okay, through which something is taken. Okay, the algorithms require that you are able to handle so many problems and solve them. For example, how can managers decide well ahead of time in the presence of uncertainty, what to produce, what to charge? How can a manager do that? You are a bank manager. You want to charge the interest rate on your customers. How can you decide ahead of time amidst uncertainties? How can you do that? What do you produce? If you're a producer of shirts and you can produce shirts, shorts, and pants, which one do you focus on producing? Which one is going to yield the maximum return? How can you assign scheduled tasks to people and manage those resources? There are lots of queues that build up when students are registering. There are lots of queues that build up when people are going to take an airplane to a place. There are queues that build up in a bank. How can you reduce those queues in order to improve efficiency and productivity? How can you do that? Management science does that trick. So daily decision, undertakings are all management science. I'm going to give you a practical example. Okay, and like I told you, the whole management science story started in the Second World War. Okay, where the British and Americans, contracted a scientist, and these scientists were to analyze military problems. Okay. And those strategic moves they made is what has led to the management science that we know today. Now you can even apply it in marketing, telecommunication, and services. So there are so many models that are in management science, so many techniques, and some of the techniques are in front of you. We are not going to study all of this. Okay? We are going to study some of them. Okay. For those that do pure management science MPhil, they will study deeper ones. But for you guys, we are going to study mathematical programming optimization. We are going to do that. Don't worry whether it's complex or not. It's not going to be complex. It's going to be simple, easier. You're going to apply it to your work. You become an optimization analyst in your company. Okay. And then they'll start raising your pay. You do that. Queuing models, we shall do queuing models. Forecasting, we shall do forecasting. Okay. Deterministic inventory models, we shall do that. Network model, I will do that with you. I will study with you decision analysis. I will do that with you. I will not do game theory with you. That is for the MPhils. I will not do Markov change. I will not do probabilistic models. So I will do the basic management science approaches with you. Okay, I'll deal with that. Okay, and I'll be doing the first one, which is linear programming. Linear programming. We call it LP. Linear programming. What is that? Well, what it simply is that it's a methodology, it's a technique that optimizes a linear function. You see, the word is linear, so you optimize. Optimize means that you're either increasing or decreasing something. You optimize a linear function subject to certain constraints. Subject to certain constraints. And these constraints are things that limit the degree to which you can achieve your objective. So linear programming is one topic we shall do. I told you about another topic, which is queuing models. Okay? You will study that. I will do a practical analysis of queuing models here in this course. We are going to help. Queuing models are useful for managers to understand how to reduce the queues or the waiting lines in any company. So imagine you have this knowledge. You're able to help a branch of a bank that is loaded. Before the branch is opened, so many people are queued. Okay? So many people are queued. And then you use that waiting in line model to help management to cut down the queues. How much money would they pay? Okay. You learn that. DEA, we shall do this one in second semester, and for those who want to really do their PhD and even their thesis here, you can come and I'll give you some topics in this area to write your long essays or thesis. It's a linear programming methodology for assessing the efficiency, relative efficiency of firms. So when you compare EcoBank with Ghana Commercial Bank, which bank is good? Whatever answer you give me, I will tell you that you are a liar because it's a subjective answer. It's based on what you've heard. It's not based on an objectively quantitative analysis. And that analysis is DEA, data envelopment analysis. It is a typical technique in management science. Okay. Let me tell you award-winning applications of management science. Number one, there is a management science group who were employed by American Airlines. This group used forecasting and optimization models. We shall do forecasting, we shall do optimization. They use those models to create discounts for the airlines, okay? And this helped in managing their revenue. In fact, after some years, they were able to realize, just 1 year, they were able to realize $1 billion in revenue. $1 billion in revenue per annum, just using the forecasting and optimization technique. So that tells you that this management science you're about to do is solidly grounded in real life market systems. It is real, it is practical. It is not just mathematical jargons. It's not Einstein jargon, it is real. In China, they were able to optimally select and schedule massive projects for the country when it comes to energy. In 1995, they saved $425 million just using optimization and scheduling, which I do both in this course. So you do a lot of consultancy. In South Africa, okay, the Defense Force were able to use optimization, linear programming techniques, and they were able to redesign the size and the shape of the Defense Force. In 1997, using the technique you guys are going to learn, they saved $1.1 billion using management science technique, which we will learn. Some of you are already consultants in waiting. There was a bank, okay, in California. They used data envelopment analysis, and they were able to improve the branch alone, the one branch, the productivity of the branch and the profits. They identified $6 million annual expense savings. In other words, they would have spent $6 million. They saved that money, identified the inefficiencies with the system, which financial ratios, accounting ratios could not do. And they applied it to 33 of the branches. DEA is a management science technique. So, ladies and gentlemen, you are not going to learn something rough. You are going to learn something that is applied, that the world has used before and saved a lot of money. And if you understand the mental gymnastics of this course, you will have enough knowledge and you can be a great consultant to your company. But let me go deep and let me go very simple and tell you how practical management science is in your daily living. Let's say you took a flight from Kotoka International Airport. You are just going on a holiday in London. But before you took the flight, you have to select the best flight, the cheapest flight. So you go to Skyscanner. Those of you who have been traveling a lot, you might know about Skyscanner. You type your from, okay, and then your to, and the day and the time you want to travel and all of that. It will tell you the cheapest fare that day or that week. And what you don't see is that the thing will tell you loading, loading, loading. There is an algorithm behind the computer, behind the scenes, developed by operations researchers or management scientists. This algorithm is going to search millions and millions and millions of options to find the cheapest fare for you. You are just watching the computer screen, just like a baby, but behind the scene, a lot of algorithms, management science techniques are in operation. Wow, you get a cheapest fare. You fly from Kotoka to London. The moment you get to London, okay, you have already arranged, another algorithm has already scheduled the flight crews and the aircraft used by the airline. It's done that. When you get to London, another algorithm has selected a London cab, which is coming to pick you. But what you don't know behind the scenes is that the price you're going to pay the cab is determined by a mathematical model that seeks to maximize the revenue of the car rental company. Management science is at play. Just you don't know that. But those who know. And so management science is practical. You can use management science to be able to optimize certain things that are being underutilized. It's something that is not yet being fully applied in most African countries, but I tell you, in most departments abroad, in US, Canada, Australia, and several places, people are using management science techniques, especially in the UK. We use this to be able to optimize a lot of revenues, okay, of some companies in London. So it's a technique you want to learn. It's a technique you want to apply. It's a technique you want to love. It's a technique you want to learn and to teach other people. It's practical. Okay. And so we'll be using models. We even be developing models. And at this stage, I want to tell you the simple meaning of models. Guys, models are not difficult. What is a model? A model is a representation of reality. Put that down. If you are taking notes, write that down. A model is a representation of reality. It's a model. It's a model. It's a representation of reality. When you take a picture and you look at the picture in your hand, that thing there is a model. It's a representation of you, who is a reality. But the thing is that if you experiment with models, it's better than when you don't experiment with models. Because if you want to do an experiment, it's better to use a model than to use a real thing. Let's say that you want to know the different parts of the brain. It's better to actually use a model, than to actually use a real life human brain. A real life human brain. Okay. You can use a model. Suppose you want to manipulate an airplane. You want to know where the avionics is. You want to know how functional the avionics is and all of that. It's best to get a miniature version than the full-size airplane. Because there's miniature version, you can manipulate, it's cheaper. It saves less time and then money to be able to manipulate that one than to go and use that miniature version is a model. It's a model. And we can manipulate models. So in management science, we are going to write models, create models, manipulate the models. And then once we have an understanding about the behavior of the model, we can now apply it to real market systems. That is management science. Why do you use the models? Because you can manipulate them easily than the real life. Models can help a manager to identify a profit without even producing and selling the product. You can identify the profits of your company when you have not sold the product, and yet you are clear of how much profit you're getting. Model will help you to do that because you have a representation of the reality. Models will help you reduce the risks. But the beauty of a model depends on how well it represents the real world. Because if the real world, you're not representing it well in the model, even if the model is good, it will not be able to mimic the real world, okay, even in a bootstrap world. Okay. And so it's very important to get the right models. And then you can manipulate that right models. So that when you get into the real world, you can manipulate the real world. The first model we'll be dealing with, the first technique we'll be studying is known as linear programming. Guys, if you have a big notebook, write it down in the book, linear programming. You see, when you do that, what it does to your brain is that it helps you to know that you are about to embark on a journey. What is linear programming? Well, first of all, it comes from what word? Can you type it there for me? What word does it come from? Linear programming. It comes from what word? The word is a 4-letter word. What word is that? Excellent, Alekim. Excellent, Kelvin. Excellent, Danielle. Excellent, Francis. It's a line. The word is a line. It's a line. It's a line. Fantastic. Good. So linear programming is one of the mathematical models. It is designed to help managers plan, decide ahead of time, make profit, given the limited resources they have. Okay, now let's get a bit deeper. So let's say that you want to solve a lot of problems related to management, scheduling, media, financial planning, capital budget, transportation, and all of that. Linear programming will do that for you. It will do that for you. So let's get a little bit into the history. I normally don't teach this one either, but a brief history is that it's a model that was developed by, it was first formalized by a man known as Kantorovich in 1939. Kantorovich did it. It wasn't really used much until George Danzig came around in 1947 and made it operationalized. Okay. But what does it do? Well, for linear programming to work, certain things must be in place. When Koopmans came in 1948, after the 1947, Koopman coined the term linear programming. And so people sometimes tend to think that Koopman was the one who actually brought it, but it was Danzig who used, because at that time there were not computers. So he was the one who used the simplex method in 1947. And it is a tool that we use to solve this linear programming problem. So there's a problem. There's a problem. Marital problem is there. There's a problem. Financial problem is there. You can talk about a problem. You can formulate the problem. Now, in the world of linear programming, what you do is that you formulate the problem into a linear programming problem. You formulate a problem into a linear programming problem. Once you have formulated a problem, now we solve the problem. We solve the problem. So what are the things that you need to be able to know that this is a linear programming problem? What are the things you need to know? Well, ladies and gentlemen, I want you to pay attention, please, here. So these are the basics. The first thing I want you to note is that you have something we call a decision variable. Okay, now we call it DV, decision variable. Now the decision variable is that, okay, the decision variable is that sort of thing, that thing you are looking for in the problem to solve the problem. Okay, so let's say that you want to make a profit in a company, but you can't make a profit unless you have sold something. What is that something? That is the solution to the problem. And that is the decision variable. That is the thing you got to decide on how many of that thing you're going to produce or you are going to bring to the real world. How many of that? Once you know that, then you know the problem. Okay? That is a decision variable. And in this course, you are going to master how to identify the decision variable. The second thing, so please know the decision variable is that solution to the problem. And a lot of people think that the solution to the problem is when you make a profit. No. That is a target coming out of the solution, because you can't make a profit out of nothing. You got to make a profit out of something. That something is the decision variable. The next thing to note, which is another component of the linear programming, is parameters. That is, the parameters are the objective item. So is your objective to minimize cost? Is it to maximize revenue? Is it to maximize profit? Okay, so that objective, the parameter is the profit. The objective is whether you are minimizing or maximizing. Okay. And so you got to know, and this one is very simple, because you know that if I want to talk about distance travel from Accra to Kumasi, who can tell me, do I want to increase the distance or I want to reduce the distance I travel from Accra to Kumasi? That will let you know straight away the objective. Do I want to increase the distance or reduce the distance? Who can tell me? It is to reduce, minimize, exactly. It's to reduce the distance. Okay, so that is obvious. Now let's take something like the audience. I'm doing a program at the National Theatre. Okay, I'm doing a program at the National Theatre. The number of audience. Okay, the number of audience. Do I want to reduce the number of audience or increase the number of audience? Which one? Do I want to reduce or increase the number of audience? Exactly, you want to increase. Exactly, you want to increase it. So that is the objective. And the audience become the parameter in question. So please note, it's not all the time going to be cost or profit. Now let's take that you are a small business SME. Okay, your revenue. Would you want to increase the revenue or you want to reduce the revenue? Do you want to increase the revenue or reduce the revenue? You know, when your colleagues are saying it, say some more, because your death is actually achieved when you don't say some of these things. Okay? You want to increase the revenue. That's it. Okay. Now, let's say that you are a bank and you have some customers who come to actually deposit money in the bank. Would you want to increase the customers or you want to reduce the customers? Okay. Increase or reduce the customer base. You want to increase it. Okay. So now let's look at you are a viral company. We're a viral company. You produce vaccines to cure COVID-19. Would you, and you see COVID-19 there. Would you want to increase COVID-19? You want to reduce COVID-19? I think that one everybody knows the answer. So that is the objective of the objective parameter, the component. The last one is that you can't do any of these things without hitting a wall. You can't just get up and increase revenue or increase profit or reduce cost or reduce distance or reduce COVID. You can't just get up. There's something constraining you. There's something limiting your movement, restricting you. And you got to take note of that constraint. So the final element in a linear programming problem is constraints. Time is a constraint. You don't have time. We all have 24 hours a day. We are limited by time. Labor is a constraint. You can have a company, you can't get more than 10 people in that room. You need a maximum of 5 people in the room. So you are limited by the number 5 human beings. Labor is a resource constraint. And there are 2 kinds of constraints you're going to experience here. One of them is a resource constraint, and one of them is a mixed constraint. Take note, we'll talk about them. Resource constraint and then mixed constraint. Materials you will need to be able to do that production. So let's say you're talking about production of some farm milk. What are the materials that you need? Okay. All right, Elikim, you have a question? Okay. What are the materials that you need in that production? Elikim, ask your question.
Sir, my question has to do with the objective. Is it always to maximize or minimize? Can it be something like maybe stabilize or?
No, you're either maximizing or minimizing.
Okay.
Right. Yes, because it's already stabilized at the time you wanted to do it.
Okay.
So leaving it as it is, then you're stabilized. But if you're going to do something there, you are maximizing or minimizing. Money is a constraint. Money is a constraint. You are limited by money. So all of these constraints will have to be formulated. All of these constraints will have to be formulated. Now, when we meet next time, what I'm going to do now is I'm going to explain linear. You see, everything I've told you is like a theoretical jargon. And I'm an applied scientist. And so what I'm going to do next time is I'm going to take a particular simple example. Okay? I call that example a Farm Milk Ghana Limited example. And I will use that example to actually teach you how to start and work with linear programming model. I will use that example.